Okay, today we're doing 4.3. It's all about isosceles and equilateral triangles. It's right in your notes, right after what we did yesterday, so find it. We're going to start with some vocab. So, an isosceles triangle. You should already know this, but write it down again. It's good information. An isosceles triangle is a triangle that has at least two congruent sides. We call the legs the ones that are congruent. So like a typical human has two legs, an isosceles triangle has two legs, all right? And then the base is the other side. Sometimes it sits on the base, sometimes it doesn't. So don't be misled that the base is always the part that it's sitting on. That is not true. The base is the third side, the one that's not congruent to the other two. And then by the base, you'll have two angles. Those are called base angles. So they are across from the legs. So if you're looking at the two legs, across from one leg, you have a base angle. Across from the other leg, you have a base angle. So when you have an isosceles triangle, if two sides of the triangle are congruent, then the angles opposite are congruent. So if you know that these two sides match, the angles across from those two sides are also congruent. So if you know the sides are congruent, you know the base angles are congruent. The cool thing about this is it works in reverse too. If you're given that the angles are congruent, you can also conclude that the sides are congruent. So it works forward or back. It's an if or only if then statement. If or only if then statement. Yes. I know. So if and only if the two sides are congruent, the base angles are congruent. All right, so number 1 in your notes looks like this. I'm going to add something so we have a little more information to go by. Add a 24 on that other side. So, what am I given right now? What's congruent?
The sides. The legs.
The angles. Do you see how these angles at the bottom are congruent?
Yes.
If those angles are congruent, I automatically know that the sides across from those angles are also congruent. So I can write an equation. 2y plus 4 equals 24. And then I can solve. Subtract 4 from both sides. And then divide by 2. And what do you get y to equal? 10. Good. What are your questions so far? All right, number 2 just popped up there. So what do I know in number 2? I'm given that these sides are congruent. So I know that the angles across are also congruent. X equals 60. Is there anything I need to solve? No, it's already done. The X is already isolated. You're good to go. Questions on 1 or 2? So what they gave us is that the base angles are congruent. So these two angles are congruent. What do I know about the sides? They're congruent. So I'm going to set these equal. Then what? Y equals 12. Good. Any questions? In number 4, I am given that this side is 6 and this side is 6. They're both 6. They're congruent. What does that lead me to know about the angles?
Your base angles are congruent.
The base angles are congruent. So I can set angle K equal to angle L. Well, angle K is 75 degrees. Angle L is 5x plus 10 degrees. And I need to find the x.
Can you put it the other way so we still?
Uh-huh. Yeah, if you want the variable in the front, I think that's the way most people prefer it. I just did it this way. I don't have a good reason why. Okay. Yes, x equals 13. This one's a little tricky. Does anyone have any thoughts? Yes, sir.
65 plus 65.
What now?
65 plus 65.
What are you going to do with 65 plus 65?
Put them together. Subtract it from 180.
Yes, way to go. Okay.
Oh, Jarvis in here doing math.
So, all right. You guys ready?
No.
Ready now?
Yes, ma'am.
Okay, so yes, you were correct. The x is down here. If the x was over here, we'd be good to go. Just say they're congruent and equals 65. We're looking for the other angle, though. So the congruent sides tell us that this one and this one are going to be the same. 65 and 65, but I'm looking for the other one. So you are absolutely correct. We do 180 minus 65 minus 65, or you can add 65 and 65 and subtract that from 180. Either way, what do you get? 50, yes. You don't really need the degree symbol since it's already written after the x. On number 6, I am given that angle P and angle Q are congruent. What does that tell me about the side lengths? These guys are congruent. So I am going to set 4x plus 4 equal to 32. 4x equals 28. X is going to equal 7. Good. Raise your hand if you have any questions. So here are some facts. If a triangle is equilateral, what does it mean to be equilateral? All the sides are the same. If all the sides are the same, all the angles are also the same. Once again, this one works in reverse. So if you know that all the angles are the same, you also know that all the sides are the same. This, what they just did, is called the converse. It's where you flip-flop the if and the then part. So in this case, the converse is true, and that's how you get that statement I was saying earlier, if and only if. It's called a biconditional statement when it works forwards and backwards. All right? So equilateral gives us equiangular gives us equilateral. So in number 7, we are given that the 3 sides of this triangle are congruent. If the 3 sides are congruent, the angle is 60 degrees. X is already by itself, so you're done. That could have been like 2x plus 14 or something, and then we'd have to solve for the x, but x is already isolated. We're good to go. Raise your hand if you have any questions. All right, now it's in reverse. So I am given that all the angles are the same. They didn't tell me what the measure is. You should know the measure is 60, but it's not really important on this one. What's important is to know that they're all the same, which means that all the sides are the same.
Yours don't have a 27.
These are 27.
There's a 27 there? Well, thanks.
So do we put both of them equal to 27?
Well, so you could do it either way. Actually, you could write 3 separate equations and get the same answer. What you could do is what I was going to do this to begin with. I was just going to set the 2 sides equal. Or, now that yours has the 27, you could set one of the sides equal to 27, or you could set the other side equal to 27. Either way, we should be getting the same x. I'm going to solve it the way I had intended before I knew the 27. So I got that x equals 4. We can just verify that on all the other ones for fun. X still equals 4. I'm just having fun, you know, math. So yeah, any of these equations would be a valid way to do this problem. You're actually probably given too much information with that 27 present. But there you go. 3 different ways to find the same correct answer.